Hi there. So we are continuing the discussion about land and shifting our focus now to agricultural practices. The first thing that you should note is the core case study at the beginning of chapter 12. Um, all of chapter 12, for the most part, is devoted to agriculture. So the case study is addressing the problem of food deserts. There are a lot of food deserts in the United States. A food desert is a place, generally an urban area, where people do not have access to nutritious foods. This is actually considered an environmental justice issue. There's an estimated 23.5 million Americans in the United States who live in food deserts. So people who live in food deserts generally would not have reliable transportation to get to a grocery store, and so are relying on convenience stores or gas stations and fast food for most of their meals. So this has a lot of health impacts by eating very high fat foods and not getting enough vitamins and minerals needed for a healthy life. The case study actually really focuses, though, on an urban farm called Growing Power Inc. It was actually started by a previous pro basketball player named Will Allen. I don't know him, maybe you do. But he started this urban farm in Milwaukee, Wisconsin. And the farm has been very successful. It's an ecologically based farm, which basically means that it's run in a sustainable manner. It utilizes solar electricity and solar hot water. They have a lot of greenhouses, so they're relying on solar energy to grow food year round. They're producing a lot of different varieties of food, which is all organic, and also they are producing chicken and turkey and goats and fish and honeybees. And from all of their plants and animals, they're recycling their nutrients. So one way in which they're recycling their nutrients is by having hydroponic systems where they are cultivating fish, but then using the fish waste as fertilizer to grow things like lettuces and other greens that grow well in water. They also have an educational program that kids can visit. They've partnered with the city to create jobs for low-income or unemployed workers. And also they're offering deliveries for people for a low cost to get fresh produce at their home. We do actually in New Orleans have some enterprises similar to this. There's the Holly Grove Farmers Market that you can sign up for produce deliveries, and I believe that Grodat Youth Farm also is starting to do this. So anyway, this is just an important case study for you to understand and just to know that urban farming is becoming more popular to address the need of people living in these food deserts. Okay, so this is just an overview of what sections we'll cover to talk about agriculture. So you can see pretty much, well, all of chapter 12. You also might want to take a look at deforestation in chapter 10, section 1. I didn't actually include that in this PowerPoint, but you should just glance over it. We will kind of go to that later on in the year. And then also there is some information about irrigation in chapter 13, sections 2 and 5. Okay, so sorry, this is the core case study again. Let's just, oops, okay. Here's the core case study. Sorry, I thought I had it pulled up. Okay, let's go here. All right, so why is good nutrition important? We know that we need proper nutrition to live healthy, long lives. And there are different types of obstacles for people living in different parts of the world in getting good nutrients and getting nutrient-rich foods. So about 800 million people on the planet are not getting enough to eat. They are suffering from chronic undernutrition. This is mostly in less developed countries where people are not having diets with a lot of protein, but they're mainly relying on carbohydrates, like mostly eating grains. And we might say that they're living low on the food chain. This is generally touted as a good thing, and it really is, like eating food that does not require a lot of resources to sustain it. But if you're not including protein in that or important vitamins and minerals, then you can have health problems. So this is just saying what, we need both macronutrients and micronutrients like vitamins and minerals. So people who aren't getting enough protein can suffer from malnutrition or chronic malnourishment. Of course, then we have the opposite problem in highly developed countries where people are getting too much fat and sugar and salt. But going to places where people are suffering from malnutrition, oftentimes there's problems with famine. So this can be this is a severe food shortage that leads to mass starvation and deaths, and can also cause both economic and social problems in the countries that famine is occurring in. Usually it's due to crop failures as a result of drought or flooding. It can also be due to war and other events like this. Okay, so looking at micronutrients, so these are your vitamins and minerals. About 2 billion people, mostly in less developed countries, are suffering from deficiencies in vitamins and minerals. A lack of vitamin A, for example, can cause blindness. There's a lot of children in the world, I think about 250,000 children in the world who are going blind every year, and about half of them die very soon after. Too little iron in your diet can cause anemia. And then there's the lack of iodine. So iodine is necessary for proper thyroid functioning. And without enough iodine, you can have problems in like stunted growth, mental retardation, and the development of goiters. So this is where there's a severely swollen thyroid gland. So you see people walking around with a big bulge in their neck that's called a goiter, and it can lead to deafness. About 600 million people in the world suffer from goiters, and about 26 million children in the world are suffering from brain damage due to lack of iodine. Okay, then there's the health problems associated with eating too much. So we would call this overnutrition. The thing about overnutrition is it actually has very similar health effects as undernutrition. So these would be things like lower life expectancy, greater susceptibility to disease and illness, as well as lower productivity and life quality. So the countries with the most overweight and obese people would be the US, no shock there, China, India, Russia, and also Brazil. Right, so what are the root causes of hunger and malnutrition? Poverty, of course, is really what's preventing people from having access to nutritious foods. So a term that you can use to address this access to nutritious foods would be food security. Food security, aside from poverty, can also be impacted by war, corruption, weather events like droughts or flooding or heat waves, and also climate change. And so a central question for us really to consider is how can we feed everyone on the planet without damaging the environment more than we already have? Because combined with these things that we can't necessarily control, food security can really be in jeopardy for these billions of people that we have on the planet. Okay, so moving on to agriculture, how is food produced, right? So we have high input agriculture and low input agriculture. And we'll talk about those in a second. There are three systems that really supply most of the world's food and use about 40% of the world's land. The first would be croplands that produce grains. This accounts for 77% of the world's food. The rest is supplied by what we call rangelands, pastures, and feedlots to produce meat and meat products. And then we have fisheries and aquaculture for fish products. These three systems only rely on a handful of plant and animal species. So of the 30,000 plus known edible plants, we really only use about 14 to supply 90% of the world's food calories. Most people survive by only eating rice, wheat, and corn. And then also only a handful of mammals and fish are utilized for providing food or for providing protein to most of the world. So we would call this food specialization. And the problem with only relying on a few species like this is that it really makes our global food security vulnerable to things like disease and climate change and environmental degradation. Since the 1960s, though, there's been a really large increase in global food production due mainly to three technological advances that are listed here, which include irrigation and the use of synthetic fertilizers and synthetic pesticides. Okay, so again, as you saw on the two slides ago, there are really two major types of agriculture: high input industrialized agriculture and lower input traditional agriculture. Both of these together have really increased our global food supplies. Industrialized agriculture relies on heavy equipment, a lot of money, fossil fuels, a lot of water, and also commercial inorganic fertilizers and pesticides. Usually with industrialized agriculture, farmers are producing single crops. We call these monocultures. And the goal of industrialized agriculture is really to try to increase the yield of these monocultures. So trying to produce as much food as possible on the same amount of land, or looking at the amount of food produced per unit of land. This type of agriculture produces about 80% of the world's food, but only is practiced on 25% of cultivated land. Plantation agriculture that you see at the bottom here is a form of industrialized agriculture that's used in less developed, usually tropical countries. Cash crops like bananas, coffee, soybeans, sugarcane, palm oil are grown on large monoculture plantations and are then usually exported to more developed countries. Okay, so the second type of agriculture is this low input agriculture. This is what we consider a more traditional agriculture, and this takes place on 75% of the world's cultivated land, but it only provides about 20% of the world's food crops. So when we're talking about low input agriculture, there are two different types. The first would be traditional subsistence agriculture, and the second would be traditional intensive agriculture. So both of these types of low input ag use human and draft animals for labor, but subsistence agriculture produces just enough food to provide for one's family with very little left over, while the traditional intensive agriculture really aims to increase crop yields with more intensive labor, still using humans and draft animals, but really working a lot more. And also, these types of farmers would use organic fertilizers like animal manure, and also would be irrigating their crops with water. So this would allow farmers to not only feed their families, but generally have a little left over that they could sell to get some income from. So at the top here, you can see it says traditional agriculture often relies on low input polyculture. So what this is saying is that most traditional farmers are growing a lot of different types of crops on one plot of land. So this would be the opposite of that single crop monoculture practice. So we call this polyculture. Polyculture is really good because the various crops mature at different times. So these farmers are able to harvest food throughout the year. And also, because of this, it keeps topsoil covered. So in the last video, I was talking about problems with topsoil erosion. Polyculture is great to reduce topsoil erosion from wind and water. Polyculture also generally requires less fertilizer and less water because of the different varieties of plants, and because their roots would be targeting different sort of layers of the soil, so those horizons that we've talked about, so they can utilize nutrients and water much more efficiently than when you have a monoculture that would be getting all their nutrients and water from the same depth of the soil. Also, weeds are not as successful as growing in polycultures, just because there's so many different kind of plants and densities that they have to compete with. And polycultures are also really good because farmers don't have to worry so much about conditions that they can't control, like extreme weather events. So remember, we've talked about in less developed countries, oftentimes people are relying on just one type of crop for their economy. So this traditional sort of subsistence living provides much more food security, even if it's not bringing in a lot of money. Another type of polyculture that you should be familiar with is slash and burn agriculture. This is where a small area of land is cleared and burned, generally in tropical forests like in South America and Africa. So what happens here is farmers go in, clear, burn this land, plant various crops on it, and just grow and grow and grow their food on that land until it basically becomes depleted of nutrients. And then they just move on to another plot of land. And then over time, of course, it will become regenerated and be able to be used again. But they have to go on to a different plot of land in the meantime. Okay, so another type of agriculture that we need to talk about is organic agriculture, which is becoming more and more common. So organic agriculture involves growing crops without the use of synthetic pesticides or fertilizers, and also without the use of genetically engineered seeds. Organically grown animals, if animals are called organic, they can only be fed using 100% organic feed and can't have any antibiotics or growth hormones used. If something is labeled as 100% organic or like USDA certified organic, that means that the product only contains organic ingredients and was grown using only organic methods. There are about 2.2 million farms in the United States, and of these, only about 13,000 are certified organic farms. So I said what it means for something to be 100% organic or USDA organic certified or certified organic. A food can also be labeled as just organic, which means it contains 95% organic ingredients. Something could be labeled as made with organic ingredients, which means it must contain at least 70% organic ingredients. And then food may be also labeled as natural, which really has no actual requirements for organic ingredients. So your book says that this is really just an advertisement ploy. I'll let you decide that. So organic agriculture is more labor intensive than our more industrialized agricultural practices. So the foods usually cost more. But really more and more organic farmers are trying to figure out how they can get higher yields of their crops while keeping costs low. So the guy in the case study, Will Allen and his farm Growing Power and their associated farmers are trying to do this. They're trying to figure out how can we get more yield and keep costs down. Okay, so this is figure 12B, I think, in your textbook, and it's just showing, this is figure 12.7, so just showing differences between industrialized and organic agriculture, and I'll just let you read those on your own. Okay, so looking closer at industrialized crop production, to produce more food, basically farmers have two choices. They can either farm on more land or they can try to get higher yields on their existing land. Since 1950, 88% of the increase in global grain production has been due to this high input industrialized agriculture increasing crop yields. And so this is referred to as the Green Revolution. The Green Revolution involves 3 steps. First step is developing monocultures of high yield crops that are either selectively bred or are genetically engineered. So these would include rice, wheat, and corn. The second step is to produce high yields of these crops using large amounts of water and synthetic fertilizers and pesticides. And then the third step is increasing the amount of crops grown per year on a plot of land. So that's what you see here with this multiple cropping. So between 1950 and 1970 is what we call the first Green Revolution, where crops in most of the world's highly developed countries were substantially increased. The second Green Revolution began in 1967, and this is where rice and wheat production increased in middle income, less developed countries like India, China, and Brazil. And this was through introducing really fast-growing varieties of the rice and wheat. It's called the Green Revolution here, or the second Green Revolution, because introducing these fast-growing varieties really actually has helped to protect biodiversity in these countries. So because of the high yields that these varieties produce, it's protected places like wetlands and grasslands and forests. And so you can see here, from 1950 to 2014 or present, really, world grain production has tripled. Something that you should note is that farm subsidies have been very helpful for expanding industrialized crop production. In the United States, these subsidies generally go to corporate farming operations for corn, wheat, soybeans, and cotton. And so 75% of the subsidies recently have gone to just about 10% of farmers in the United States. Okay, so the last thing that we have two things to talk about. We need to talk about this agribusiness and also genetic engineering, and then we'll leave off for now. So this is the case study on agribusiness. So U.S. industrialized farming has really shifted to agribusiness or evolved into agribusiness, where you have a few big multinational corporations that are controlling more and more parts of agriculture in the U.S. and global markets. Industrialized agriculture in the United States has doubled crop yields without needing to use more land since about 1960. So this is really successful, right? It's a lot of food that's being produced for the people who need it. And it's kept a lot of places from being converted to farmland. So like we talked about just now with the second Green Revolution, industrialized food production has been really good for saving places in the United States. So saving more natural places from being converted to farms. Because of the efficiency of this food production, Americans really don't have to spend much of their income relatively on food. So we spend about, on average, 9% of our income on food, whereas people in less developed countries spend anywhere from 50 to 70% of their income on food because it's so much more expensive. But of course, what you need to keep in mind is that while we don't necessarily spend a lot, like when we walk into a grocery store, there's a lot of hidden costs to our food production and our consumption, and this makes the actual food costs much higher than market prices. So these external costs would include things like taxes to pay for these farm subsidies that are going to these big corporations, and also costs of environmental degradation and pollution and the associated health costs. Okay, then let's talk about genetically engineered foods or GMOs. So farmers have pretty much always relied on artificial selection and breeding to increase their yield and to improve the variety of crops and livestock that they produce. The problem with this is that it's really slow and it can only be done with genetically similar species. So now we have genetic engineering where we can actually insert the traits of one species into the genes of another. And so this is through something called gene splicing. Genetic engineering takes a lot less time than artificial selection. It costs less, and you don't have to have similar species to do it. So there's a lot of good reasons to rely on genetic engineering. About 50% of the world's genetically modified crops are planted currently in the United States. Okay, there is controversy. Of course, I'm sure you're aware of some controversy over GMOs. The European Union restricts the use of genetically modified seeds and also the importation of genetically modified products. So we really don't yet know the long-term ecological effects or human health impacts of genetically modified organisms. I personally think that the ecological effects are what we need to be focusing on. Biodiversity could be threatened due to high use of herbicides with GMOs. Herbicides impact pollinator species, and also GMO genes can spread to non-engineered species. And so this can result in decreased biodiversity, which leads to less resilient ecosystems. And so with changing environmental conditions and more environmental, degradation that we are creating, this decreased biodiversity could be problematic. Another problem is that companies basically rent their genetically modified seeds to farmers. So traditionally, farmers will save seeds for the next growing season, but because of them now having to rent seeds, it's much more costly to the farmers. And this is figure 12B in your textbook, just listing pros and cons or potential pros and cons of genetically modified crops. So some of the pros are it can be more resistant to insects, disease, and environmental changes. They could possibly grow faster. They might be able to tolerate higher levels of herbicides and maybe need less fertilizer and water, as well as potentially could have a longer shelf life. Some potential cons are that we don't know the ecological effects yet, as I mentioned already. We may be increasing toxins in our foods because of high use of herbicides with GMOs, and we could or GMOs could repel or harm pollinator species. Also, the high use of herbicides and pesticides could end up leading to resistance of these, and then also, of course, as I said, could eventually reduce biodiversity, and finally can be very financially harmful to our farmers. Okay, so that was a long video, and we're going to leave off there, and I will see y'all tomorrow.